Okay. Now, trigonometry is one of the most ancient subjects studied by scholars all over the world. It was invented because there was a necessity for that. Like astronomers used it to calculate distances from the Earth to the planets and the stars. It was also used in geography and navigation. Knowledge of trigonometry is also used to construct maps, determine the position of an island in relation to the longitudes and the latitudes. This is all from your textbook. Then a surveying instrument, which is known as a theodolite, was invented, which is based on the principles of trigonometry, which is used for measuring angles, the rotating telescope. So this whole instrument is actually based on the angles, the line of vision, and the object. So we will see, I'll share another application with you. These all things are there in your textbook actually. So before we look into this, I would show you another slide on this. Now,
Welcome to TUTE. In the last session, we studied about trigonometry. In this session, we will study application of trigonometry. Before knowing what are the application of trigonometry, you should know the following terms. First, line of sight.
this is
Second,
very essential.
horizontal level. Third, angle of elevation. And fourth, angle of depression. Let's see, what do you mean by line of sight? Consider a boy standing on the ground and a tower which is at a certain distance. That boy is watching the top of the tower. So that imaginary line is called as line of sight.
Are you all clear about this?
Yes, yeah.
Yes,
Yes,
ma'am.
ma'am.
Now, as soon as you answer me, then and there, mute yourself, please.
Line drawn from the eye of the observer to the point in the object viewed by the observer is called line of sight. Let's see, what do you mean by horizontal level? A boy is standing on a ground at a certain distance from a tower. That boy is watching exactly straight to a certain point on the tower. That imaginary line is called as horizontal level. So horizontal level is the line of sight when the person is looking at a point in an object. That line is called horizontal level. Horizontal level is always parallel to the ground. Now let's.
Is that okay with it? Children, is
Yes,
that
ma'am.
okay?
Yes, ma'am.
Okay.
Yes,
So we learned
ma'am.
about line of
Yes, ma'am.
sight and the horizontal level. Horizontal level is one of the most essential things because you need to know the angles made between the line of sight and the horizontal level. So it's always parallel to the ground. I'm moving ahead to the third major term.
What do you mean by angle of elevation? Consider boy standing on a ground. He's at a certain distance from a tree. So this will be his horizontal level. That boy is watching the top of the tree. So that line will be line of sight. These two lines make a particular angle. That angle is called angle of elevation. So, angle of elevation is the angle between the horizontal line from the observer and the line of sight of an object. That is above the horizontal line. Now let's
So this meant, what did this mean? That whenever we are looking up towards something, like when I was discussing in the classroom, when we are looking up towards the fan, then there goes the angle of elevation always. Fine with that? Now moving ahead to the last angle. Now children, please mute yourself when I'm speaking. So going
see
ahead.
what do you mean by angle of depression. Consider a building, and on the top of a building, a boy is standing. So this will be his horizontal level. The boy is looking at the base of the tree. So that particular imaginary line is called line of sight. These two lines make a particular angle, and that angle is called angle of depression. So angle of depression is the angle between a horizontal line from the observer and the line of sight of an object that is below the horizontal line.
Okay with that? Now the thing is, we have done these 4 terms. Have you written them down somewhere? So we started from line of sight. Please put today's date. Put down the important terms. Just write line of sight, horizontal level, angle of incidence, and angle of depression. So as you see, all of them are actually made by the horizontal and the observer. But the line of sight keeps on changing. Once it goes from the observer up to the object and another goes down to the object. So it's all depending on the relative position of the observer and the object. Are we clear with that? So moving ahead again. So these 4 points are what we just now spoke about. I hope everybody writes down these terms as important terms. Okay, we'll stop it here now. Fine with that. So at least you got some idea about how we are going to start the topic. What are the 4 important points? Am I right about it, children? Okay with it? So now moving ahead. So here is what was there in your textbooks actually. This is what was there in your textbooks. So here again, the same thing in 9.2, you can see the height and distance where from A to C, when you're looking up, this is your line of sight, angle of elevation. Again, here the same thing, angle of elevation they're talking about. Moving ahead to depression, angle of depression. A person is standing on there on the first floor, looking at an object which might be any sort of football or something. Here is the horizontal level. Please mark this. This horizontal level and the ground level are parallel to one another. So in this case, you have this as the angle of depression. Can you see that, children? It is the angle between the horizontal level and the object, line of sight. Now, can I ask you something? If horizontal level, this line is parallel to the ground, can this angle be equal to this angle?
Yes, ma'am.
Yes, ma'am.
Yes.
Ma'am.
How? How?
Yes, ma'am.
How?
Alternate interior angles.
Interior
Angles.
Perfect. Perfect.
Interior
Perfect. Alternate interior angles. Done with it. Now, if I say this child is not here, this girl is not here, but the girl is here, and the object is on the top here. Fine. So in that case, the line of sight remains the same, but from below to top it goes, right? So in that case, this becomes what?
Angle of elevation.
Angle of elevation.
Perfect. Perfect. So this is your angle of elevation. So in that scenario, can I say that angle of depression and angle of elevation are the same?
Yes, ma'am.
Yes, ma'am.
Can I say? Because you only said these are both alternate interior angles, right? So whenever angle of depression will be given to you, remember that we have the angle of elevation also given in that case. because most of the sums that we would be solving as problem sums, in those, if they are giving you the angle of depression, always understand that the angle of elevation is also given to you. Right with that? Can I proceed?
Ma'am, so
Yeah.
only the horizontal level will change.
Yes, only the horizontal level will change. So when the child, the person is standing here, observer is here, the horizontal level is here. When the observer comes down here, the ground becomes the horizontal level. Okay with that?
Okay. Yeah.
Now, I would like you to see one more side before we start solving some examples from the textbook. Herein some nice examples are only there. So I would like you to start jotting down once we begin. Can you all see that?
Module, you will learn
Children, are you all ready? Can you see? Okay, I'm
Yes,
moving.
ma'am.
how to calculate height and distance.
I would request all to mute, please, because if I'm again muted, you can't speak to me.
Using trigonometric ratios. In everyday life, we come across many buildings, monuments, and other structures. The heights of these structures can be found using trigonometric ratios. Let's review some basic terminology associated with finding heights and distances. Suppose an observer is looking at the top of a tower. The line joining that object and the eye of the observer is called the line of sight. The angle between the horizontal line and the line of sight, which is above the observer's eye, is called the angle of elevation. Suppose the observer is standing on the edge of a cliff and observing a boat on the water. The line of sight will be as shown. Here, the angle between the horizontal line and line of sight, which is below the observer's eye, is called the angle of depression. Let's see some examples on how angles of elevation and depression can be used to find the heights of the objects. A pole of height 25 meters stands vertically on the ground.
I would want you all to start, you write there down examples and number one, and it's better that you take down the question fast. And I want everybody to sketch a diagram faster. Can you hear me, all of you?
Yes.
Yes, please. Take down, just draw the diagram and see if it matches with the actual one or not.
The angle of elevation of the top of the pole from an observation point on the ground is 45 degrees. We have to find the distance of the point from the pole .
Giving you 1 minute of time to write down the question and draw the diagram.
Done, ma'am.
Let everybody finish it up. This concept should be should seep into you all, please.
Ma'am, should we solve it?
Yeah, start. Diagram is ready?
Yeah.
Start.
Let Mn represent the pole and the point from where the top of the pole is observed be P. The angle of elevation from point P to the top of the pole is 45 degrees. We need to find the distance of the point P from the foot of the pole M.
Okay, all of you have drawn the diagram and some of you have even started solving it. So was your diagram looking like this?
Yes, ma'am.
Fine. So if Mn is the pole standing there and here is your angle of elevation, because NP is your line of sight here. Here you observe as a point object. and MP is actually the ground, which is the horizontal level here. So they are asking us to find MP. Now, what do we use? There are three basic standard ratios that we know, trigonometric ratios: sine, cos, and tan. Done. So when we need to find MP, what do I use? Sine or cos or tan?
Ma'am, you can use cos 45.
Cos. But they are asking us to find
Yeah, you
MP.
can.
Tan.
Ma'am, you can
Tan.
tan.
Tan. Directly tan. Because tan means
45 is
tan is perpendicular
Ma'am, but-
upon base. Yeah, tell me, who's that? Tell me.
Ma'am, MP is adjacent.
No, MP is the base.
Yeah,
This-
it's the base.
Yeah,
And
this is a perpendicular. This
we
is the
already
base.
know. Yeah, we know the perpendicular. So if we use
Hmm.
cos 45, can't we find
No, cos
MP
45
because
is what? Cos 45 is what? Curly brown hair,
Base.
base by hypotenuse. You don't know the hypotenuse. NP, you don't know, right? So tan 40. And what is tan 45, children?
1.
One. Perfect. One. So you have NM is equal to MP because both are equal, because tan 45 is equal to 1. So I hope everybody has memorized by now, or if possible, have that thing open in front of you. The table is given in your textbooks. I told you people to keep it in front of your study table. For now, keep it in front of your table, study tables. So we
Ma'am.
move ahead.
Yeah.
Yeah, tell me.
Ma'am, it's a isosceles triangle, so
Yes,
Wait,
perfect.
like without using
automatically MP will become
automatically
20.
the opposite sides are equal.
Yeah.
Perfect. Perfect. Perfect.
Triangle NMP is a right-angled triangle. In the triangle, tan 45 degrees is equal to MN divided by MP.
Everybody will be writing it down, please.
Let's substitute the value of MN. MN is equal to 25 meters. The value of tan 45 degrees is equal to 1. Rearranging, we get the value of MP, that is, the distance of the foot of the pole from the point, is equal to 25 meters. Let's look at another example. A boy standing on a tower observes a ball on the ground
Please start writing and draw the figure.
at an angle of depression of 30 degrees. The ball is located 60 meters from the foot of the tower. Let's find the height of the tower.
Write down the question in short is fine. And then start sketching it, doing that diagram. Done?
1 second.
1 minute.
Please try to draw this angle of depression.
Done, ma'am.
Done? Okay.
Done, ma'am. Done, ma'am.
Surely the diagram is also done, children.
Done, ma'am.
Yes, ma'am.
The angle of depression. Let AB represent the tower. The ball is located 60 meters away from the foot of the tower. The boy observes the ball at an angle of depression of 30 degrees.
This is what you people have done. I need to see the angle of the horizontal level and the angle of depression very clearly into the diagram. Now, if this is 30 degrees, which other angle will be 30 degrees, children?
Angle
Angle elevation.
Perfect. ACB. So this angle becomes 30 degrees angle, and that is nothing but the angle of elevation. Because here, if you see, we don't have any triangle information, PAC. But ACB, there is a triangle. There's again a right angle triangle. This is a right angle there. Fine with that? So here, if we have this as 30 degrees, the tower making the perpendicular and CB, which is given to us as 60 meters, is the distance. Now they are asking us to find AB. Basically, we are finding AB.
When this line is joined, a triangle is formed. Here, the side AC makes an angle of 30 degrees with the horizontal AP. Considering the side AC as the transversal of parallel lines AP and BC, angle ACB and angle PAC form a pair of alternate angles.
This should be seen in the diagram that this is 30 degrees and this is again 30 degrees. And then you move ahead taking care of trigonometric angles. Now, which ratio shall we use here?
Tan.
Again, tan.
Tan 30.
Perfect. Again,
Tan
perfect.
30.
They are equal. Therefore, angle ACB is equal to 30 degrees. In the triangle ABC, tan 30 degrees is equal to AB divided by BC. Substituting the values, tan 30 is equal to 1 by root 3 and BC equal to 60 meters. We get AB by 60 equal to 1 by square root of 3. Rearranging the expression, we get AB equal to 60 by square root of 3.
So we are rationalizing the denominator. Always. Never keep square root sign in the denominator. Mute yourself, children. All of you will mute yourself. Whenever you want, I'm asking something or you need to ask something, unmute.
On simplifying, we get 20 multiplied